In this section, we're going to go over how to plot density of state files using NRLMOL. For this, I will be following the instructions set up in the website on the Electronic Structure Lab, plotting density of states using NRLMOL. So for this, we are going to use as an example, the TCNE benzene molecule we've used in the past. And for this structure, it's actually made from two components. Let me just open it here with JMOL on a directory where I have previously run the density of states calculation. So I'm going to open JMOL with xmol.dat, and here you can see that, let me rotate it a little bit. You can see that actually it's made of two components. The one on the left being the benzene, and the one on the right being the TCNE. So to request a density of state calculation, let me close JMOL here. That means that in the NRLMOL input.dat file, you have to set an option there to Y. Let me just do vi NRLMOL input.dat, and on this option called dos_b, you have to set it equal to Y, and that controls the calculation of density of state file. Normally it's set to no, but if you put Y there, then after the SCF conversion is achieved, it'll create files. As you can see here, they're called DOS-O 001, 002, and so forth, all the way to DOS-O 22. That is one for every atom. Okay, so in order to plot the density of states, we have to create what we call membership files. These membership files are a file that will define which indexes contain to what structure. And that is because, and here's an example of the cluster file, and NRLMOL actually orders the atoms. Once it does the calculation, it puts carbons first, then hydrogens, and then nitrogens. Here you can see they're not in that sequence. So therefore, after this is executed, from the xmol.dat file that is created, you can see now here that we have the carbons first, then we have the hydrogens, and then finally we have the nitrogens. So therefore, the order that these atoms have is the same order that the DOS files have. That means that DOS-001 belongs to the first atom, DOS-002 belongs to the second atom, and so forth. The only problem we have here is that which carbons belong to the benzene and which carbons belong to the TCNE. In order to do that, normally we open the structure again with JMOL, xmol.dat, and if you put the mouse cursor on top of each atom, you can see what its index is. So let me put it on the first hydrogen on top, and you can see that's atom number 13. So in the xmol file, the 13th atom should be a hydrogen, which is this one. And for the carbons, you can see that this is carbon number 1, the one on top, then followed by carbon number 3, number 5, and so forth. So from there, you were going to select only the DOS files that correspond to this structure and put it in a file called benzene.mem. And for the TCNE, we're going to do the same. We're going to find out which atoms belong to this structure and then put them in a membership file of their own. So let me close JMOL here, and let's go back to the web page. And as I said, here's the membership for the benzene. 1, 2, 3, 4, 5, 6. That means the first 6 atoms are carbons from the benzene, and then 13, 14, 15, 16, 17, and 18, which are the hydrogens. Okay, those make up the benzene. So the membership file will be for the TCNE, which is only 10 atoms. The membership 7, 8, 9, 10, 11, 12. Okay, which are the carbon atoms, and then 19, 20, 21, and 22, which are the nitrogens. So that'll be the membership. So we have to create a membership file for the benzene, going back. In this membership file, the first line it's going to have is how many atoms. Okay, in this case, for the benzene, it's 12, atoms 1 to 6, and 13 to 18. They don't necessarily have to be in order. I just did it here for clarity. Okay, so for the TCNE, we have the first line on the membership file, which is 10, then 7, 8, 9, 10, 11, 12, which are the carbons, and then 19, 20, 21, and 22, which are the indexes from the XML file that correspond to those atoms. Okay, we have to also create a total membership file, and that one is trivial, which is just a file that will contain on the first line 22, and then the numbers 1 to 22. Again, they don't necessarily have to be in order. We just do that for clarity. Okay, so once we have these membership files ready, we can use the GUI to plot, actually not to plot, to generate data files for those memberships. So let me go back to where we have the GUI, the NRLMOL GUI, and run it with java-jar NRLMOL GUI.jar. Once this open, I have to first set the project directory. In this case, will be the TCNE directory where I have my membership files, and go into the viewer and then plot density of states. Okay. Once I select plot density of states, this menu comes up, and from here I have to select the membership file that I'm going to use to generate a data file. So first thing you do is select a file. In this case, let's use menzin.mem. What file type of file it is? It's a membership file. Okay. The density of states file can have different prefixes. You can see it's DOSO, AF10, AF20, minority and majority. In this case, it's DOSO. So I'm just going to create a data file. Okay, and I'm going to call it benzene dot. Sorry, I don't have to put the dot file. Sorry, it creates it by itself. Okay, so I want to plot the Fermi level, so you can go ahead and tell me what the Fermi level is for this structure. So I press OK. So here we go. The Fermi level is 5.619. Okay, so I'm going to jot that down just for reference. And here's the plot for that structure. Okay, this plot's not actually the final plot. This is just done for reference. We're actually going to make a stacked plot with this, the benzene, and the total. Okay, so as I said, this is just a reference. So now let me select the one for the TCNE membership. Okay, and here I'm just going to call it TCNE to create the dot file. As I said, you don't have to put the DAT file, it puts it in automatically. That means that a data file is created for that membership. Fermi level again. Okay, there it is. So here's a plot for the TCNE. And as I said, this is just for reference. I can close this. And let me do one for the total. So you're going over here and get the total membership file. It's again a membership file. And just call this total.dat. Well, total, but actually the dot file, the DAT extension will be added automatically. In this case, I already took the Fermi level. I don't need to put this anymore. So I'll just do this. This doesn't have the Fermi level, but I already jotted down what it is to put it into the other files. Okay, so that's it. I can just now go and exit the GUI, go back to my directory. There. And you can see that for the total.dat membership file, which was just a text file, I have now a total.dat. Okay. For the TCNE membership file, I have TCNE.dat file, and same for benzene. Okay. So this dot file is actually the addition of the individual atoms that make up the benzene, and they're put together into this dot file, which is now used for plotting. Same for the TCNE dot. Okay. Let me just open for reference the TCNE dot membership, bi TCNE dot membership, and as I said, it's 10 atoms 7, 8, 9, 10, 11, 12, okay, 19, 20, 21, and 22. So that means that the GUI took these files, DOSO 007, DOSO 008, and so forth, added them all up and put them into the TCNE.dat file that I can now use for plotting. Okay, so in order to plot, I have this prepared plot file. You can also get it from the website. Okay, it's a script that will work with GNU plot. So all you have to do is just run GNU plot with it, and that'll create a file that is now ready to be further refined. Here you can see on the top part is the TCNE, on the bottom part the benzene, and on the bottom part we have the total, which is the addition of all the DOS files for all the structure. Okay, so this file you can further refine using a graphics editor or even a presentation editor. Okay, so I also did an extra file, which is the Fermi file, the Fermi.dat file. Okay, I just rounded out this to 5.62. Okay, so I made this file that just creates a vertical line. Okay, as you can see, these are XYZ pairs. The first point is located at the Fermi level on X, 0 on Y, and the second point will be the Fermi level on X and 70 on Y. It's just being cut off from the graphs. Okay, so I just used that to print that red line that was on the graphs. Okay, so this concludes this section.